Okay, about 10 minutes into the experiment now. The cell voltage is still 1.86 volts. It's gone down a little bit, and now we see some first small bubbles, but not much coming up. Gonna have to steer a bit again. Let's see. Voltage rising again a bit. 1.88. Okay. Voltage still 1.88 volts. Not any visible hydrogen production in this moment. Well, what I wanted to say, the short circuit current in this moment is pretty low because first the graphite-paper electrode has a pretty high inner resistance of a few kilo ohms, or at least 1 kilo ohm in that range. And then you also have to see that the distance from the alufoil and the graphite-paper electrodes, the current must go, because it works like a pump, like a volt pump. The current which goes out of the circuit and comes back to the electrodes must also go inside the cell from one plate to the other. So the electrons have to cross the electrolyte, and if the electrolyte also has a pretty high inner resistance, then the current will be low, because all these resistances add up in this circuit loop. So if we have all these resistances, inner resistance in series, from the alufoil through the electrolyte, through the graphite atoms or molecules, up until the wire is connected, then we have maybe 2 or 3 kilo ohms, and that will surely put a resistance onto the cell. So we only get at 1.8 volts about, or 1.9 volts, we can only get 1.4 milliamps, as you can see now. So if we can make the resistance of the whole cell lower, then we surely also get much higher current, as I have shown with the help of the stainless steel mesh which I put previously into the graphite. So this already reduces the inner resistance of the graphite electrode, and if we make the distance from the alufoil to the graphite paper still much less. So if you put the plate just over top of each other with only a few millimeters of electrolyte between it, then surely the inner resistance of the electrolyte is also much lower. So still in the short circuit mode, still 1 milliamps now flowing, so it's pretty stable, around 1 milliamps now. Okay, switching back again to the voltage setting. My finger got a little bit brownish from the potassium permanganate. Okay, okay, that's the voltage again. Now again recovering, already 1.5 volts, going back up to about 1.8 volts again. So only a few bubbles now visible, so the hydrogen production is pretty low in this moment, because the alufoil is decomposing slowly. Yeah, but you can see that's a pretty interesting cell, and not too bad in its output if you do it right. If you try to decrease the inner resistance of the cell. Okay. Really big. 1.67 volts, still rising. Okay folks, this is it for now, and I will work now to optimize all the cell and take more notes and longer duration tests, and try to drive a 1 watt LED with it. Put a few cells in series. Always remember, if you do experiment with these cells, it's best to minimize the output current. So just don't put these cells in parallel, because then you also have currents which goes from one cell to the other cells, which is to lead out or to compensate their cell voltage. That is not too good. Just put all these cells, just these galvanic cells, also if you do Joule Thieves, put all in series, so you get higher voltage and still small current. Battery cell is always good to don't draw much current from it. So better do all your battery experiment with putting all these cells in series and use high voltage and low current. Then this way you can really achieve longer running time of your motors, which you connect to the batteries. Also, if you do some kind of scooter experiments, just better rewind your motors so they have high voltage coils and not low voltage current coils. Big current coils are not good for motors. You just go by the experience Mr. Joe Newman got. Just use very little current and high voltage, and then your motors will run much longer from the same battery capacitance, because this battery will discharge much slower, and slower discharge and high voltage back current pulses via inductive kickback are always good, so you can recharge your batteries. And yeah, we will see how this works out. Okay, bye bye for now, and just use these tips to build your batteries and Joule Thieves and see what you can get out of it. And always put these cells in series, so you have a high voltage, still low current, but current times voltage gives you the output power. And if you stack these cells in series, you also will get higher output power and won't discharge your cells too soon. Okay, bye bye, have fun, goodbye.